Welcome to Data Viz with Class. I'm Caleb Class, and today I'm going to show you two ways to make a heat map in R. One using ggplot2 to visualize a long data table, and one using the pheatmap package to visualize a wide data table or a matrix. And I'll show you how to reshape data from a wide data table to a long data table or the other way using the tidyr package. First, let's talk about what a heat map is. A heat map is a graph that uses color to represent numbers. So imagine if the number you want to visualize is a temperature, you could use a heat map to show how hot or cold it is in various areas. This will be way easier to understand than if you just cover the graph with numbers. I also learned that this is not a heat map. If you're filling different shapes with colors, that's called a choropleth. Maybe choropleth, choropleth. But if you want to just call it a heat map, I won't yell at you. Choropleth is hard to say. Today, instead of showing you how hot or cold various areas are, we'll use a heat map to track how popular or unpopular various baby names have been over the past 100+ years in the United States. First, I'm going to do a bit of data prep using dplyr, so hang out, we'll do that together. Or if you want to check the chapter guide, you can skip ahead to see me make the dang heat map. Today's data comes from the US Social Security Administration via Kaggle. You can always load it in by finding in the file menu and clicking on it. I'm going to use the read CSV function from the tidyverse. You need help finding the file in your R script. You could always try the getwd function to check your working directory. So I just need to go few files in. I found the data set and loaded it in, and we can see we have 4 columns: name, gender, year, count, over 2 million rows. We could look at the top of this data frame just to see them. So we have the year, the name, the assigned gender, and how many babies were born with that name in that year. Let's start with my name, Caleb. Never liked the name Caleb that much, but it seems to be coming on lately, thanks to some other Calebs who are much cooler than me. So let's see how that name's been doing over time. If you watch the dplyr tutorial, you should be able to do it yourself. Try using your own name. Pause for a minute and see if you can. Did you do it? Awesome. Did you not? That's all right too. Here's what I did. I filtered by my name. I also filtered for males only. If you didn't do that, you might have seen a funny graph because there are lots of names that both males and females get, and ggplot would have tried to connect them and made a weird zigzaggy graph. So after we filter, all we need to do is set x equals year, y equals count, how many. We're just going to do a line plot for this one, and there we have it. So almost no Calebs in the US till around 1970. Then we see a big jump all the way to 2000 or so. We see a peak at 2000. I wonder if I peaked in 2000. No, I sucked in 2000. I'm better now. So after about 2005, we've had a big drop off. Maybe it's starting to sneak back up again. That was pretty easy, wasn't it? Next, instead of just looking at one name over time, let's look at the top 10 names over time, and let's look at both males and females. So we've got 20 names to track. We could put 20 different color lines on the same graph. That would be really hard to understand. So a different way we could do it is using a heat map. So in this heat map, we'll still have year on the x-axis, but now the y-axis, instead of being the count, is going to be the different names. And then going across from 1900 to 2000 whatever, the color is going to say, has the name gotten more popular or less popular? So we're not ready to do this yet because we have way more than 20 names in our data set. So now we need to have some dplyr time to get our data ready to make this heat map. We're going to start with a group mutate to rank the names every year. So I'm going to add a column that says within each year, what was the rank of that name? So we're going to group by year to say what are the most popular names within year. We also need to group by gender to say what are the most popular boy names and girl names within each year. After that, we will add a new column using mutate. We'll call the column rank, capital R, equals, and we're going to use the rank function to actually calculate the ranking for each year within each gender. So rank of count, if we see what we came up with, we can see that actually the lowest count got the highest rank. So just like when we use a range, if we want to go high to low instead of low to high, we need to use the descending function. You could also, instead of using the descending function, you could use a minus sign. It does the same thing. But we can use descending. And now we see that Mary was the #1 girl name in 1883, followed by Anna and Emma. So now I've got the rankings. Maybe I want to make a heat map showing how the popularity of the top names has changed over time. So let's say I want to focus on the top names from the most recent year in this data set, which is 2022. I can't just filter for rank is less than or equal to 10, because that will take the top 10 names from each year. I just want the top 10 names from 2022, but then I want to show every year for those names. So I'm going to filter another table that just shows the top 10 names from 2022. And all we need to do is filter for year and rank. So you can see we have 20 rows, top 10 female, top 10 male. We can then go back to our original data set and we can filter for the names that are in this top 10 list. So it doesn't matter what rank they are each year. If they were in the top 10 in 2022, then we will take their data from every year. Go ahead and view. We can see we've got some females named William and James listed in 1883. Nothing wrong with that. But they are not 2022 top 10 female names, they're top 10 male names. So we need to do a little more filtering. How we will do this is by going back to this top 10 data frame, and we are going to do a mutate to make a new column that combines name and gender. There's other ways to do this. I think this is the easiest one. We can use the string concatenate function. This is basically the same as the paste function, if you know that one, but this is the tidyr version, so that's what we're going to use. So we are going to combine the name column with the gender column. We will separate it with an underscore, so we can see that Olivia is one of the top 10 female names, James is one of the top 10 male names. So we'll filter our original data table using that now. So now I'm going to go back to what we did before. We'll use the name gender function, and we will use this same concatenate in our original data frame to filter for that. Now we can see we've got the top 10 girl names, the top 10 boy names. You note that Luna is a top 10 in 2022. Back in 1883, only 17 girls named Luna. Now I will go ahead and save this as names top 10, and then we are ready to make that heat map. So let's make that heat map. Remember, this is a long data table. That's exactly what ggplot likes. So we're going to say year to the x-axis, name to the y-axis, and count to color. So this will be just like any other ggplot function. Names top 10, send it into ggplot. X is year, y is name, and we're actually going to set fill equals count. To make a heat map, we can use the geom_tile function, and there it is. So we did it. Doesn't look amazing, but we can kind of get the idea. So just like I said, year is on the x-axis from 1880 to 2022. The names are on the y-axis, kind of in reverse alphabetical order. Maybe not the best. We could use different functions to reorder that if we wanted to. Our fill is count, the number of babies named that every year. That's a number variable. ggplot has a default color scale from that, going from very dark blue to very light blue for very high numbers. And we can see that a few names, James and William, went absolutely nuts in around the mid-1900s. They've dropped off since then, but they're still the top 10 names. It's kind of hard to see the rest of the names. You can see a little bit of light blue here, but we might change our color scale to improve this. So one way to make it easier to see the full range is using a log scale. Probably the easiest way to do that is just put log 10 around counts. So now 1 becomes 0, 10 becomes 1, 100 becomes 2, and so on. So remember, before we had our cuts at 25,000, 50,000, 75,000. Now it's at 10, 100, 1,000, 10,000. And we can kind of see the small numbers better. We can see the big numbers kind of worse. So we might want to adjust it even more. So I'd suggest a diverging color scale for this. So we got a kind of neutral color in the middle. We'll make it white, but you could choose something else. And then as a name gets hot, we'll make it red. As a name gets cold, we'll make it blue. There are lots of scale color and scale fill functions that will help you with this in the tidyverse. For this one, I'll suggest scale fill gradient 2 to do a diverging color scale. We could use the defaults for this if we wanted to, but I'm going to set the colors as well as the midpoint. For low, let's go with dark blue. The midpoint, we will use white. And for high, we will use red. We will also set what the midpoint should actually be. I'm going to suggest 3. That's 1,000 babies. So if there are more than 1,000 with that name that year, it'll start turning red. If there are less, it will be blue. See how that looks. Not bad. I think it's a little better. So there are still a few issues with this heat map. Probably more importantly, notice these blank spots. These are where a name wasn't recorded in a certain year. There were less than 5 babies with that name, so fewer than 5 babies named Mia each year up till around the mid-1900s. So really we would want to fill these in as dark blue. You could handle this with dplyr, but I'm going to show you a way to handle this using a different heat map library called pheatmap. To use pheatmap, we need to transform our long data table into a wide data table, or a matrix. We want the years as rows, the names as columns, and then each number filling in the table will be how many babies had that name each year. So I'll start with my names top 10 table. We don't need gender in this one, so I'll select to remove that using the minus sign, and then I'll use pivot wider to turn it into a matrix. The first option we need to set is names from, which says which column of our original dataset becomes the columns of our wide dataset. So I will turn names into columns, and we need to say which column of our original dataset becomes the numbers in our matrix, and we want that to be the count. It seems to sort the years kind of random, so we're going to go ahead and arrange the years. Arrange year, we want from low to high, so we'll leave it like that. We will also save this new data set as the names matrix. So now we have years as rows, names as columns. Each number says how many you had. Finally, I want to add values fill. What this will do is it'll fill in all the blanks. So you can see here in A, in 1961, no babies named Luna. So instead of having that as a blank, I'm going to set that to the lowest number in our data set, which is 5. So we're going to fill all the blanks with 5. That will make them nice and dark blue on our heat map. And there you have it. We changed our long data table into a wide matrix. If you needed to go the other way, you could instead use pivot longer. We would first say which columns we want to pivot longer. I want to pivot every column except for year because I want the year column to stay as the year column. Then we will just give names for the new columns we're making because the columns that we are now pivoting are the baby names. We're going to set the numbers that we are pivoting into counts, but we'll call them babies this time just so you can see the difference. So we took our wide data table. Now basically we're back to before, year, name, how many babies had that name each year. Finally, time to make our heat map using pheatmap. We can make one just using the names matrix. Based on how we set it up, our years are rows, our names are columns. I would like to flip that. We can flip it easily using the transpose function. That's just T in R. So T, the T function means transpose, flip rows and columns. Next, you'll notice that our year column is mixed on the heat map with all the names. We do not want that there. So we'll select that out using select. If we wanted to, we could label each column with that year, names matrix $year, but there are way too many columns. That does not look good. We will leave that out. So let's talk about clustering. By default, pheatmap will cluster both your rows and your columns, and that's a way of showing which things have similar patterns to each other. So it's going to show which names have similar patterns over the years. It'll also show which years have similar patterns of names. So I don't really want to cluster years. I would rather just see the years go from beginning to end. So I'm going to remove the clustering of the years using cluster calls equals false. So that is just an option in pheatmap. Cluster underscore calls is false. Now yours goes from beginning to end. So now if we look at how the names are clustered, we can see that William and James have very similar patterns, had a huge peak in the mid-1900s. They've dropped off since then, but they're still the top 10 in 2022. Other names have had some popularity in the past, but not as much. And some names are much more recent. So one benefit of clustering is now we can see, instead of just going alphabetical order, we can see that William and James have very similar patterns. They're way different from everyone else. That's what the height of this dendrogram shows. You have to go way up high to get from those two names to everything else. That shows how different they are. Let's go ahead and do our log 10 trick again. We're just putting log 10 around our data. And remember, now we're going 10, 100, 1000, 10,000 and more. So maybe you like this way better, maybe you like the other way better, just depends on your data set. Another thing pheatmap lets you do is scale your rows or columns using the scale option. I'll let you experiment with that, see what you think. One last super useful thing pheatmap lets you do is adding a color bar to your rows or your columns to show additional information. For this data set, we don't have much additional information, but we could go ahead and add a color bar showing the gender. And to do that, we need a separate data frame that has our names as the row names, and then a column that says gender. We'll set this up as a data frame, data.frame, and all we need is gender. We will grab that from our top 10 2022 data table. Remember, all that was the top 10 boy-girl names from 2022, and we will set the row names of this to the names from that table. Top 10 2022 dollar name. We look at annotation. That's all we have. Data frame, the names, and one column. pheatmap can add an annotation or a color bar to your columns using annotation call, but we want to add a color bar to our rows, so we will use annotation row. And we are just going to set that to this annotation data frame. There you have it. You could change the colors for your color bar if you wanted to. You could change the colors for the color scale if you wanted to. I'm not gonna, but you should experiment with that using the options. So what have we done? We've made a heat map using ggplot2. We made another heat map using pheatmap. We even added a color bar, and I think we did a great job together. If you want, you can experiment using the color palette options. You could even go down to the comments and let me know your favorite color palette, or you could let me know what I messed up or how you might do it different, or you could let me know what you'd like me to make videos about next. Thanks for joining me. Hope you have a fantastic day.